Welcome, everyone, to today's webinar. This webinar is titled Solely Anywhere, Enabling Remote Asset Management with IoT Connectivity. I'm your host today, Jim Hassman. I'm the president and CRO of Blues. And I'll be introducing our guest, Jeff Crystal, here in a moment. But just a quick soundbite on Blues, who we are and what we do. We are a hardware and SaaS company that helps anyone from founder startups to Fortune 100 companies who have ideas for building intelligent connected solutions to bring those solutions to life faster than anyone. I think our customers would agree with that. We solve the complexities of having to deal with many integrations, many vendors, firmware, certifications, routing data from the cloud, managing connectivity. We handle all of that seamlessly for our customers, and we do that by virtue of two of our core products, one of them being a hardware module called the Note Card. And there are many versions and different offerings for the Note Card, depending on where people are in the world, what type of connectivity they need, whether it's satellite, cellular, Wi-Fi. We include connectivity in those little modules, and those modules get embedded into an electrical hardware solution, and that module generates the connectivity needed for that solution. And the second core product we have is the companion SaaS solution to the Note Card called Note Hub. Note Hub is where you manage your devices, manage your fleets, perform firmware updates, and most importantly, route your data to any cloud endpoint. And we do that all very seamlessly and at securely and at scale. We've been doing this for about 8 years now and have hundreds of enterprise customers that rely on our solution every day for building intelligent connected solutions. So that's Blues. Thank you all for joining. Now to our guest, Jeff Crystal. He joins us from Voltaic Systems. He's the Chief Operating Officer at Voltaic, and I'll open the floor to Jeff, let him introduce himself, and let him introduce who Voltaic is, what they do, and how they got to where they are. We'll start there, Jeff.
Right. Thanks, Jim. Can you hear me okay?
Yes.
Okay, great. So Voltaic Systems, we design a range of solar power solutions for a lot of different customers. The bulk of our customers are doing some sort of embedded application that's sitting outside in the world that needs power, and solar is often a very good way to do that. And so you can see some of the panels behind us. And then we're also now building a larger scale system that looks like this bigger system here that powers higher energy devices that are typically sort of in the 0.5 watt to 15 watt continuous draw. And we use Blues on that system, so we'll talk about that.
That's great. For those of you joining, Blues also uses Voltaic. And so there's a reciprocal relationship that we have here. In fact, the first product that Blues created, I don't know if you all know this, but it was this product called the Air Note. It's an outdoor air quality monitor, and that is a Voltaic solar panel that sticks on the outside of a window of your school, campus, industrial complex. Mine's at my house. You scan this little QR code. It's wife-proof. You just scan it, the app comes up, and you can start seeing the outdoor air quality at wherever you're at. But we do use Voltaic's solar panel here. Jeff, tell us a little bit about how Voltaic got into this business. Where did it start, and how did you find your way to where you are today?
So it's a little bit of a meandering journey, but we've been doing, we're now almost like fully an industrial company, but our first product that we made was a solar backpack. So we were the first company to build a backpack with an integrated solar panel in it. And it got a ton of attention. It was really popular. But what happened was we spent a lot of effort on the sourcing side and understanding how the interplay between solar and batteries work. And we ended up building solar panels that were way too well built for a backpack, and understood sort of the technology of how a charge circuit in the solar works. And so we started decoupling it, and that led to people buying, in the hundreds, and then the thousands, and then the tens of thousands, and then the 50,000s of panels to build into their product. Because if you're putting something, on a shipping container, our $5 panel, if that fails, it's a $400 replacement cost. So we got really good at sort of building these robust small scale systems. But what happens, Jim, as you know, is you build a product, it's out there, and people come to you and say, what do you have that's bigger? Or what do you have that can produce more power? So there's sort of a way to do this. So if you had a device that's drawing a lot of power, and we got a lot of requests from the LoRaWAN gateway community, like the Things Network, there's a way to do this. You take like a big lead acid battery, you put in an enclosure, you put a solar panel on it, a charge controller, you connect the panel in to the charge controller, and you got a large system. And we were sort of hesitating, like, this maybe isn't what we want to do. This works well enough. And then one of our friends in New York, he was building they have a flood monitoring system all throughout New York. They have these sensors, and he said all their gateways are grid tied. We want one that's backed, off solar. So if we have flooding again in New York, like we did, through Sandy, we still have monitoring. And so we built it. And I carried a 100-pound battery on my head up a ladder, and it took us
Sounds super safe.
Took a long time to source all the components. And we're like, this is bad. If you're going to do one system, you can live with sort of the suffering. But if you're going to do hundreds of systems or 1,000 devices, you can't. And so we decided to build basically a solar power system that replicated but improved on sort of the classic ideas of a lead acid system. But with using lithium iron phosphate, which shrunk the footprint, got rid of the charge controller. But then what you're thinking of is, and how we came to Blues is, you're like, okay, I've got a $300 to $1,000 solar system on a pole. Maybe the installation cost for getting a technician out to that site could be $500, $1,000 easy. And then I'm running a $3,000 camera. And then I'm sort of imagining, okay, you get the phone call that says the system's not working. And so how do you address this issue of expensive assets in remote locations, relying on your product and not having monitoring? And it sort of sent fears up my spine. So that's when we came to Blues and said, okay, we came up with sort of internal thing that we need to monitor the system. And then the question is, how do you do it?
So you had some early access to Blues and what we were doing. I mean, you've got one of these little note cards that is helping collect data from the performance of your systems. Tell us a little bit about that journey of like why Blues, what was appealing to it, and then what was the problem that, I mean, you touched on a little bit of it. What was the problem that it solved for you that without Blues it would have been whatever that scenario looks like?
Yeah, I mean, I think there's sort of two things, which is like Blues or not Blues, and then monitoring or not monitoring. And I'm going to sort of mix those up maybe a little bit, but we knew Blues. Well, so your founder, Ray Ozzie, actually wrote maybe 10 years ago, wrote into Voltaic very humbly after the Fukushima nuclear meltdown. He was looking to build a way to do radiation detection in Japan because the government wasn't really doing it. And so we had a lot of back and forth around panel selection, batteries, things like that. He, was just sort of a very lovely person.
That was pre-Blues then.
Pre-Blues, it was pre-Blues. We were, so there was this lovely person writing to us, and we got to know him. And then so when Blues was started, we were aware of you. So we thought about you, and then you were at the same conferences that we were at and stuff. So we sort of had a general awareness. And so then the question becomes like, do we build this ourselves? So lots of sort of engineers like to build things themselves. I understand the draw, and it's technically possible. Like we can buy all the chips, we can hire embedded engineers. And so that was sort of one path. And then, but the issue is we've done some prototypes with Blues and our scale, and we're at, I think this week we're going to ship our 400th system with Blues monitoring device. Our scale is, I think reasonable, but not 10,000 a year. So we don't, and also we don't know what we don't know. So with Blues, I think what we looked at it, the pricing was reasonable. The at scale, so we modeled it at scale. The pricing was reasonable, and then relative to the cost of building it our own, it was just pretty straightforward. So I think what Blues handles for us is a lot of the complexity on the back end up front. I think you mentioned certification, but certification on its own can easily cost $20,000, especially when you start hitting multiple regional jurisdictions. And then, on an ongoing basis, there's this complexity of, we initially we thought NB-IoT was a good idea. And then we fairly quickly switched to Cat 1. And then now there's
as
Cat 1
has
Plus.
everybody pretty much.
Yeah. So, I mean, so we're able to make that switch from NB-IoT to Cat 1 in a, I'm exaggerating, but like in a day. But then and then to Cat 1 BIS is, I think you're doing a much longer due diligence process, and we're sort of riding on your coattails. It sounds simple, but it's like these things add up from an engineering resource perspective.
Yeah, they really do. The Cat 1 biz is interesting because I think not just Blues, but everybody's kind of been chasing that one for a little while here, waiting for modules to come out and whatnot and test it and certify their devices on it. But for those of you that may not be familiar with it, NB-IoT was this, really cheap approach, more expensive than Wi-Fi or LoRaWAN, but not as expensive as Cat 1. The problem was it never really gained market traction from a network perspective. So it had trouble connecting in some places, especially for assets that moved. It was very challenging. And so we saw a lot of people try it because it was cheap, but then say, I can't get the connection I need, and move to Cat 1, which was more expensive. Cat 1 Biz is an interesting offering because we are coming out with note cards that are Cat 1 Biz modules. They are, the performance closer to Cat 1, but at an economics that's closer to NB-IoT. And I'm not saying they're at parity, but you can it's a much more, I think, cost-effective approach for better coverage, where NB-IoT kind of failed on that. So that's interesting that you guys also had that same journey.
Yeah, and we had a customer who was like in a power plant, and they didn't want to use cellular because they actually had no connectivity, and so but Wi-Fi was an acceptable option to them from a security standpoint. And so you have a Wi-Fi module. So we're able to sort of use the same base system and expand across connectivities. Satellites, obviously, another one that we're looking at, although we haven't deployed at any sort of scale. But then what I think what was interesting about this product for us is we built it relatively quickly. So we had our first conversations on the dashboard, which is where we visually present the information in October, and we have some fairly rudimentary questions of our partners, and then started to screen that down, and we started to build a prototype with Blue's help. We did our first deployed prototype, and it's basically starting in October to roughly this in December. And so what this is we made a little board that is an RS-485 converter and a 5-volt converter to step down from 12 volts to 5 volts. And then we're using Swan, Blue Swan, and Blue's no carrier. We built that board, and then that was deployed in samples in December. It went to customers beginning in February, and then April it started to ramp up. So from just a product development time, it was quick. And Voltaic, we have lots of engineers, but most of them are mechanical with a lot of coding background, because most mechanical engineers have coding these days, but they're not embedded firmware engineers. And so for us to be able to build this product relatively quickly was because you had the parts, the Quebitro had the IoT dashboard that we're able to plug into and scale up with, and that ecosystem allowed us to go quickly.
So your product's interesting because it's really, if I have this right, it's solar panels for companies that are making hardware that need power generation in remote places. What are some of the common applications of your product that you see? And I would think that, putting solar panels out in the middle of nowhere may raise the question, is there cellular connectivity? Have you seen any issues with some of the installations of where
Yeah,
your panels are used and the Blue's ability to connect to the
yeah.
network?
So there's, I'd say remote, all the applications are in places where it's hard to get electricity. And so there's sort of two, paths to that. One is you're in a city and the cost to actually connect to the power line, either because of political reasons or just physical reasons, is too expensive. And so power is there, but it's too hard to get to. So that's, on a light pole, for example, is something that comes up quite a bit. And then the other one is, yes, it's remote. So it's on a wellhead, it's in the middle of a farm, away from power. And so I'd say our big categories of products are cameras, either for security or remote access or something like that is a big one. And I think we're seeing a lot of revs around, all the things that cameras can do on the AI side. The
Mhm.
second one is networking equipment. So LoRaWAN gateways, cellular routers, Wi-Fi routers. Someone needs to put those things with power. And then the third one is I generally classified as environmental monitoring, and that could be air quality, it could be methane detection, anything where there's often, like with air quality, if you think about like a GPS tracker, it goes to sleep and then wakes up 5 minutes, 15 minutes, or on some sort of program, and then goes back to sleep. If you're measuring air quality or methane, you can't go to sleep because it needs to be continuous. And so things that are running continuous tend to be what we're doing. But if you back to sort of when I think about what Blues does, what we're buying is time in a lot of ways. So there's a cost of our product, and we focus on our BOM and getting it down as low as possible. But the time is what we're trying to save people. So the time of you have a technician going up on a tower, is a 2-hour drive, and then you have extra bolts that you don't really need. Someone drops the bolt, you're wasting time. So how do you sculpt that down? But then also the technician connects it. We're trying to make sure that as little as complexity as possible so the technician connects it right. But what Blues does is there's a QR code, you connect it, the technician as well as sort of the person managing the project can see, okay, this thing is going. There's power coming in, I'm getting 100 watts, it's a 100-watt panel, I'm drawing 3 watts, that's what I expect. So you can give confidence to the people doing the job that they're doing a good job.
Yeah, that it's operating as designed. You mentioned earlier when you were kind of doing your intro that you were carrying a lead acid battery up a ladder,
Yeah.
and looking at the what lithium can offer. Give us a little bit of background on the transition of lead acid to lithium, and kind of what is your core when a customer comes to you now, what is kind of the core offering on the battery side? What's your recommendation?
Yeah. So lead acid is great, and I think it actually works well on a really broad range of applications. So I don't want to bash it because I think it works in many cases. I think we all know about like lithium ion batteries. The cost is dropping. If you use a lithium ion battery versus LFP, which is a newer chemistry, lithium iron phosphate has a lot more cycles. So the cells are rated for 2,000 cycles versus maybe a lithium ion battery might be 500. A lead acid battery could be it there's lots of variables here, but it's maybe 350, 500. So we have customers that were swapping out lead acid batteries once a season, which
Hmm.
is a lot. Again,
Yeah.
it comes back to that, not just cost, but time. So lithium iron phosphate has higher energy density than lead acid, so it's a smaller footprint, and lighter. So a lot of really good things. And what's been happening recently is just the cost of lithium iron phosphate cells has really gone down. And so you can build, a system like this. Here's an example of the battery, quite small. This would be double the size, double the weight. You'd probably have to put in an enclosure, which is never the right size. So then it gets bigger once again. So lithium
Does
ions, it has some drawbacks, but overall it's really, really great.
Does the monitoring device that you built with Blues, is it monitoring both the production of the solar panel, potentially any degradations in the production of the solar panel, and the state of the battery, both, or is it just one of those?
Yeah, so what we're looking at, and what we're reporting is how much power is coming in from the solar panel. So that's voltage and current. You multiply those two together, you get watts. We look at how much power is going out. So the voltage of the cells as well as the current. Again, that's watts going out, temperature, and that gives you a fairly good diagnostic of what's happening. What right now I would classify the tool as a diagnostic tool. So every customer sees this of their fleet of devices. So you have one, you have 100, you have 200 devices. They see their fleet of devices and they can see their performance. And it's quite valuable in many ways. Which I have some fun examples. But what it's not doing yet is sort of what I consider like more predictive analytics, which is to say, okay, this battery is now at 93% of its full capacity versus when you installed it. Because I think what we'd like to be able to do, let me give you an example. So we had a customer in Virginia, and they had two systems installed, and they're doing traffic, the video cameras, and it's traffic intersection monitoring. One of them was doing great, and the other one was like, hey, the system's down. And so we go and we look at the dashboards and we see, okay, this 50-watt panel is producing 50 watts, great. This other 50-watt panel is producing 25, 30 watts. And so you look at it, the options are the panel's not functioning at its full, it's somehow bad, or they point in the wrong direction.
Yeah.
And so,
Yeah,
so we asked them, we said, like, is this pointing south? And they're like, let me check, no. So then it goes into a training exercise for them to say, okay, when you install, we have some checks to make sure that it's aligned properly. But what we're not able to do yet, but it's on our, we're working towards, is be able to say, hey, this panel is performing suboptimally. You should check to see if there's either shading on it or it's not pointed in the right direction. And so if you go from sort of a diagnostic to a sort of a fleet-wide management system, is sort of the goal.
That's great. Blues may have some tools coming up that might help you with that.
Sounds
Stay
good.
tuned. Little teaser for everybody. Tell us you've mentioned the software side of what you do. Would you be able to show us
Oh,
an
sure.
example or two? I think
Yeah,
people would be interested in that.
let me get my share screen here.
And while you're doing that, maybe just a question on kind of power fluctuations. One of the things that Blues has built into the note card is the ability for the note card to kind of manage fluctuations in power. Did you ever have to change anything with the use of the note card depending on how much power was coming in through the device, or did the power management side of the note card just work kind of out of the box for you?
So what we're doing is we're taking a 12-volt power source, 12 to 13 volts, and we're regulating it down to 5. So we have our own
Modulating it down.
management chip, DC-DC converter. Yeah, so here's an example. This is a customer of ours who's not particularly large, but really great and gives us awesome feedback. But they're based in the Cape of Massachusetts, and they're running LPR cameras, license plate recognition, as well as some sort of like cache management. So if you're at like a beach, there's no power system, but you need to be able to get cars quickly into the parking lot and get them out and charge them the right amount. And so what this graph does, it shows you where it is, but also the green line is the state of charge. So we're doing what's called Coulomb counting, because LFP batteries have a very flat discharge curve. So it's hard to tell how full it is based on just the voltage. So you basically do an integral of how much power is going in versus how much power is going out, create a state of charge. But then you get to say Coulomb counting, which sounds fancy. And then below that, you can see the sort of the pinky orange, which is how much power is being produced. And what you see is these sort of these half moons. And the reason why you see this half moon is it's getting full. And so the sun comes out, the power goes up, it ramps up, it goes, charges, and then it gets full, and then it goes down again to a lower state. And then the bottom part is the purple part is the how much power is being consumed. And so there's a couple, and then below this, I'm not going to go, we could be here all day, but we show temperature because temperature can affect performance in a variety of ways. And then we go into details on the solar panel, go into details on the load. And so these are all tools that we can use to sort of see what's happening. And there's actually a cool feature now where I can zoom in on a given day. I want to see what's happening. So Quibitra just recently added this, which is cool. So there's a couple of interesting things that happened with this customer. One was December is when we size the system, we're sizing it for not for when it's now where it's nice and sunny all the time, but we're sizing for the worst times of the year, which is December and January. It's cold, short days. And so one of the systems was dying and we could see it. And if you're running an IR camera, the power consumption goes up at night. So in the winter, you have sort of a double hit of
Oh yeah.
it's longer nights and
Yep.
versus and less sun coming in. And so we talked to the customer, and they actually didn't need the IR, and so they shut down. They went into back mode, they shut off the IR, and then the system started performing again, and recovered. So there was this sort of power management aspect to it. The other thing we had was he called us one day and he was like, "The system's not working." And so this is again the dread of a technical support is they're like, why? You don't know why. But so we went to the Blues dashboard and you see, okay, wait, we have power coming in, we have power going out. So your device is actually powered. And so that actually solved, part of the problems, like what's happening. And so it was a network connectivity issue on his device, something to do with Verizon that I don't fully understand. But what he said is, can you power cycle my device? So this is not a feature yet, but what we could do is actually we went into the Blues backend node hub and we turned our load on and off using some commands, power cycled the device, started working, started connecting again. And what it sort of means, again, is back to time. We just saved him, 2 hours of a technician climbing up a pole to repair this. So that was so that's something that's in Blues that we haven't fully leveraged and built out as a feature, but it's one that I think is quite valuable.
Yeah, we do hear that a lot from customers that they love the ability to remotely manage these devices to quite an extent.
Yeah,
Changing environment variables across fleets of devices in similar types of products, doing remote firmware management, honestly, keeping the devices from ever becoming bricked because of the way that we can do our over-the-air firmware updates,
right.
recycling, repowering the device remotely. So these are all things that keep truck rolls from happening, which saves people
Yeah,
money.
yeah. No, it's when I think about like the embedded device like this on a tracker and it costs $5 panel costs $400. The dollar amount of a truck roll can be quite crazy. So we had one customer who's in like a city in Florida. They have to do it at 4 a.m. And it's like minimum of $3,500 just to get permission to get the truck on the street
Yeah.
to be able to do it. And then another one, if they're, oil and gas, it's a 2 to 3 hour drive to the wellhead. So it's just
Yeah.
not economically viable to go
You,
there.
you
And the more
mentioned
you get,
this.
that cascades.
You mentioned this. The number one objection that me and my team get when we are introducing Blues into customers is there's always some guy in the room, okay, who says, I can go buy a modem and a SIM card for whatever.
Yeah,
And they're right, okay?
they're right.
It's irrefutable what they're saying. Yes, you can. You can go buy a modem for whatever the cost is and what you get scale volume. Okay, we get the same. And then go buy a SIM card that has a data plan. When you start talking about the intangibles, though, it's really hard to put a price on, is this cheap? We're not comparing the same thing. because there's just so much that has to get built out and thought through when you're building devices that are remote, that when they go down, they cost a lot of money. And a modem and a SIM card doesn't solve those problems for you. Infrastructure solves those problems. And so I think that's what Blues really brings to the table is end-to-end infrastructure beyond the modem and the SIM.
Yeah, no, I agree. And I think we, and I think Blues does this and I think Voltaic does this, but we care about the BOM. We care
Mhm.
about how much the product costs. We want the upfront cost to be as low and sort of, I think, value focused as possible. And actually, Blues is one of the few companies that actually has dropped the prices and it has pitched us to lower cost products relatively consistently. So you have some customers who are always trying to like get a 10% increase. And on the hardware side, my experience has been the opposite, which is they're driving down the cost and they're passing those to us.
Yeah.
But so anyway, so we need to get our costs down. We need to keep driving that. But there is that it's harder to see, but it's very much important is that long-term management cost of a fleet of these things. So yeah, if you want to do one, get your modem. If you want to do 100, if you want to do 1,000, you better think it through so that you can have so you can sleep at night. And
Yeah.
where you're not gonna, if you're doing solar power, where you're not gonna sleep at night is December 27th, every year, or Southern Hemisphere June 27th. But um, it's gonna
Yeah,
happen
it's
every
the costs that
year.
people can't see that end up biting them every single time. And we see it all the time. We're not going to try to talk somebody out of their approach if they want to go build it
Yep.
themselves. We know where our value is. I just think there are costs they can't see
Yep.
down the road. We'll spend the next, whatever, 10 minutes here doing questions. There's some questions that have come in. I always like looking through the participants because I get to see that on my end. Nobody else gets to see it. And there are a lot of names on this that I have never seen before. So first of all, thank you all for taking time out of your day to join this. Hopefully this was interesting to you. Jeff and I are available for questions anytime after this if we don't get to your question. Maybe a question specifically for you, Jeff. What sizes of solar panels do you guys
Mm.
provide, and at what production capacities? What's kind of your range?
So I think at the highest volume, we're making panels like this is 0.3 watt. Our probably most popular is about a half a watt. And we're doing, again, like we're doing 1 million a year. So relatively easy to do 5, 10, 15, 20,000 batches. And then at our largest panel, we're making, this is a 25-watt panel behind me. We're making up to 100-watt, and those are fairly standard glass construction. We do a few things that we think are valuable. And we're making those in sort of the container capacity for us. So that's the panel construction is you got to do it right, but there's sort of a process to do it that we're fairly confident in.
Great. Question here for Blues. I guess I'll take this one. At what price point does Blues not make sense?
I've asked this question too, Jim. So
Great question. Um, I would, it's interesting. If you guys don't know who Ray Ozzie is, Jeff mentioned Ray at the beginning. He had the chance to interact with him pre-Blues. Use your favorite search tool, whatever it's Google, Wikipedia, ChatGPT, and ask who is Ray Ozzie. Go read about his background. It's quite impressive. But that is the CEO, founder of Blues. He is our chief architect, the creator of all of our products here at Blues, and just a super intelligent engineer. Um, the price point. Okay, Ray started this business to make it possible for any developer who might be building their first proof of concept or prototype to companies that scale to the millions. And to think about a business model where the price point specifically on the hardware and the SaaS work at that level has taken us years to try to get right. Okay. The hardware side of it, we always wanted the note cards to be low cost so that developers would be it wouldn't be an issue for a developer to go on our Shopify store and buy a dev kit, okay, for $99. We're not making money on the dev kit at all. But it's at a price point where developers will be like, yeah, I can spend 90 bucks or whatever to get a dev kit and go try my product out. To customers that are dealing with millions of units over multiple year periods, the economics have to work there. And so we've been able to create the note card in various forms, even with a version we came out with last year called Note Card XP. If you want to go to the Blues Note website and look at Note Card XP, it is a optimized version of the note card where the customer tells us these are the components we need on it. We don't need these ones anymore. That was great for our first few thousand to 10,000 units, but at scale, we don't need those. We can cost optimize it down to our cheapest version of the note card XP is $19. Which is really quite impressive when you think of everything that's packed into it. It's a 6-layer board. It's got a whole bunch of components on it you can see on the website. But our business model is to get the note card down to a cost point where it works for companies that are dealing with hundreds of thousands or even millions of units at scale. So that's that side of it. And then we have the Note Hub side of our business, which is available to anybody for developers. You get 5,000 data events in your Note Hub account per month. We just top that up. Once you get into kind of your enterprise commercial launch phase, we can provide that event capability in a capacity model, kind of like AWS does with reserved instances. We help you calculate how much you think you're going to need based on your deployment, and we give you steep discounts for using the SaaS service that way. So
The thing
that's what we'd say about the
I would
at
say,
what
Jim, is
point
that
is it too expensive? I don't know that we have found that point yet.
I would also say if you haven't built any, your model's going to be wrong. Once you build one, your model will be a little better. You deploy 100, you'll actually understand the number of things that you don't have to do, and the cost that you're not bearing. And so I think that is, it's hard to sort of understand all the costs that you would incur if you say rolled your own chip until you start using the platform at, I don't know if scale, but at some sort of reasonable number.
And tell them to go down the modem and SIM route, okay? And take another team and say, pick any Blues note card SKU that you want. Hit the go button on building your first production unit and see which team does it the fastest and see which team does it the most economically at scale. That would be an interesting use case to actually watch.
Yeah.
All right, another question for you. The Do you get questions about the security side of managing remote energy production installations? And what's kind of Voltaic's view on the security aspect related to how these systems are deployed and managed?
So, I mean, I think to some extent we're relying a lot on the encryption and the data security provided by Blues. We're not getting a ton on the energy side. I think where right now, and part of the reason we haven't rolled out a feature that allows any customer to sort of control the load is that is because of those security references. But we have and Jim, there's sort of two options here though. But like we have a model where we provide a battery in a system, and we provide an optional monitoring that uses Blues, and about 40% of our devices that go out have that. And then there's some of our other customers who say, look, I already have my cellular connectivity. I have access to I'm familiar with RS-45 Modbus. I'm going to connect into your battery and read it. So so one of my big oil and gas customers, they're doing that. But they started out with the module. So the first one we shipped the module at scale, they're doing it themselves because they have that expertise. Both are viable.
Yeah. Yeah, and just for those of you who haven't worked with the note card before, on the security side of it, when we're talking about the cellular one here specifically, none of the data that transmit from a device through the note card to the Note Hub cloud instance transmit over the public internet. It's all private VPN, TLS, and it's fully encrypted. So secure by today's standards, moving data from a device to the cloud. And you just get that by virtue of installing the note card in your product. Jeff, we're at time. Any final words for the group here?
No, I think it's been, it's been a pleasure working with Blues. I mean, we're touching probably, I don't know how many people on your team we're touching, Jim, but a lot. So we always get really good support from you. And I think we're grateful. I think, sometimes you make a choice and you're not so happy with it, but I think, we're fully we're not questioning our choice at all. We think we think we did a good job. And I think for us, if we didn't have monitoring, and I think we weren't able to build those and implement it into our systems, I think we'd be selling fewer products because it'd be harder for people to evaluate us. And I think we'd be selling the wrong product in many cases where we didn't size it right. I just avoided sending 2 pallets of the wrong size panel to a customer in Spain because the first one they had Blues, and the rest are going to have it too. But so for us, it's been sort of, I think, a money saver, but also it helps us generate revenue, which just makes it easier for ourselves and our customers to understand value.
Well, that's
Great.
great.
Thank
Well,
you.
yeah, we appreciate you taking time today. I love doing these kind of not really webinar style, more podcast style, even though I would not fancy myself as a podcaster, far from it. But I appreciate your time and all of you who joined us today. I always learn a lot doing these. Appreciate you guys at Voltaic for being a great customer. And for any of you that are interested in trying Blues out, you can go to blues.com, go look at our dev kits. One will be in the mail to you tomorrow. If you click buy today, you should have your first Blues test up and running within 30 minutes to an hour. Go build your first proof of concept. It's super fun. I did it before I joined the company, and it's cool to watch all the projects around the world and devices lighting up literally all over the planet. We can see that in our own data. It's really, really interesting. Anyway, thank you all again for your time today. And yeah, join us on the next one.
Thanks, Jim.